39, 41, 43. We will find the inverse first for the given function, and then we're going to graph it and the original function. That's the function and the inverse on the same coordinate axes, and we should see a relationship between those two graphs. They should like mirror each other. All right, so we're going to go ahead. I know you're going to ask me all three, right? Charles, read me number 39.
F of x equals 2x minus 3.
All right, and I didn't give you difficult ones to deal with.
I know how to get the inverse. It's just the graphic part. So.
Fine. So walk me through the steps. We'll go rather quickly.
All right, so we'll go y equals 2x minus 3.
So that, ladies, down out there in Google land, the first thing is replace f of x with y. Next step, Charles.
X equals 2y minus 3.
That's the switch step. At the moment those variables get switched, that y is the inverse. That y is the inverse, but we're going to leave it in place until the last step. Then we'll change its name.
And solve for x, so plus 3 both sides.
Adding 3 both sides. What comes down?
X plus 3 equals 2y. And divide by 2.
Dividing both sides by 2. That's what Charles likes to do. What would I do, Charles?
Yes,
I would multiply by 1/2.
Gotcha.
Y'all are dividers, I'm a multiplier. Alright, so now what am I going to call this y right here?
Inverse f. I don't know how to say it. It's f negative.
F inverse of x.
Yeah.
F inverse of x. I used to see myself. I don't see myself. Can I just close off the chat? Maybe my.
Yeah, that's probably what it is.
Yep. I need you to see that so I can see where to put the camera. All right. So f inverse of x is equal to x plus 3 over 2, and especially since I'm graphing, I don't want to leave that like that. So everybody, I want you to hear me say this until it finally makes sense to you, and you don't have to hear me say it anymore. Dividing by 2 is the same as multiplying by 1/2. It's the same, isn't it? Now, you can leave it in this form for graphing, or you can change it into the same form as the original function, which is slope-intercept. Doesn't matter, really, because the next job is, once the inverse has been found, graph the two of them together. All right? So I'm going to do that. Oh, one. And Charles said this was the part he didn't like. Charles, if I use slope-intercept form, that y-intercept is -3. This y-intercept, if you distribute the 1/2, this y-intercept will be 3/2, or 1.5. So, I want to keep my tickies rather uniform. So I'm going to go 1, 2, 1, 2, 3. And then I want that spacing between these to be the same spacing this way, so that symmetry between the two graphs can be seen better. Not necessary, but I'd rather do that. So I'm going to ticky this way. 1, 2, 3. And back the other way. 1, 2, 3. All right, I got all my ticks in place. Let's color code the graphs. We'll go black and green. We'll graph F black. We'll graph F inverse green. That's their speakers, but I got to hear them or I won't know they're out there. Technology, man.
Technology is buns.
For my black graph, which is the graph of f of x, y-intercept is -3. Right there. What's the slope for f? That f means function f, m is slope. What's the slope?
2/1.
Good job. We want it in fraction form so we can rise and run. So from the y-intercept -3, I rise to 1, 2. Once I do the rise, I run to the right, 1. So here comes that graph, and I'll try to find a ruler. Of course, it's a line, so it's going to keep going in these two directions. I just put arrowheads on there. So that's the graph of F. Now I'm going for the graph of G, which is F inverse. So if you didn't know what G was, I just told you it's F inverse. Now listen carefully. Ladies out there in Google World, I had them do this the other day in class. This is what happens with an inverse. If this is F's domain, and if this is F's range, then when you switch, this is the domain of F inverse, and this is the range of F inverse. So the roles switch. So to graph the inverse, I'm just going to come up here and look at these points and reverse the order. That's all. Reverse the order. So for the inverse, since F had the point 0, -3 on it, the inverse will have the point -3, 0 on it. So watch, I'm going to show you something. For F, the function F, the points that we have on it. And what was the other one I used? What's this one? 1, -1? When I say members, that means they're points that belong to the line. So for the inverse, and I'm using the definition so I don't have to work too hard. For the inverse, I just switch the order. That's what an inverse does. It just switches the order, the role of domain and range. They switch places. Are you with me?
See.
So I'm going to plot -3, 0. And I'm going to plot -1, 1. Left 1, up 1. Using my ruler, I will graph the line which represents F inverse for this problem. They do intersect right there. They intersect there. And now I'm going to tell you who that is where they intersect. They intersect along a line y = x. All functions and their inverses mirror one another in the line y = x. They mirror each other. Kind of like standing over a crystal clear body of water and seeing your reflection. That's what they do. They see each other symmetric in the lines y = x. So the green is the inverse, the black is the original function, y = x is the line of symmetry for the two graphs graphed simultaneously. That's it. That's it. All right, now we're going to do the same kind of thing we just did. We're doing it for problem number 41. The function f of x is equal to x to the 5th minus 2. And Charles and Virginia Glenn and Ethan and Sleeping Owen, I think we have to find the inverse, don't we?
I'm not.
I know. I always say that to make sure that you aren't. So I'm going to use y equals instead of f of x equals because it's easier. Switch and get what? X equals y to the 5th minus 2. That y is now the inverse. Switching the order of domain and range creates an inverse. What's the requirement for a function to have an inverse? It has to be blank to blank. 1 to 1. That means the marriage between the domain and the range has to be 1x, 1y, 1y, 1x. No multiples with a single. No. Add 2 to both sides. You get x plus 2 equals y to the 5th. How do I undo the 5th power?
Square
5th root.
Yeah.
5th root.
Yeah.
So we 5th root both sides. 5th root both sides. They undo, and that gives you y equals the 5th root of the sum x plus 2. That y is the inverse. Now, knowing how to graph roots comes from that library lesson a couple sections back. You know, library. You had the squares, you had the absolute values, you had the lines, you had the reciprocal function, and you had some root functions. You had odd polynomials, even polynomials, you had all that good stuff. So you got to pull all that up when you need it. Can you see this, Ethan? And again, we'll do black and green. The graph of f will be black. The graph of the inverse will be green. Now, even roots do this, right? Do that. Odd roots. I'm going to have to hand motion this because it'll look like you're walking like an Egyptian kind of thing. You know? It's like the odd roots. See what I'm doing? Odd roots. Now, square root, even roots don't have a double branch. They don't have any negative. Because you can only do square roots of non-negatives when the root's even. Odd roots, you can do positive, negative, and 0. 5th power, odd power. Start off increasing and end up what? Increasing. Polynomials can turn, right? But in order to turn, there has to be more than just 1 power of x followed by a constant. So this 5th power of x resembles x cubed, which is the daddy parent of all odd degree polynomials. So if you know x cubed looks like this, x to the 5th looks like that. It just flattens a little bit more. X to the 7th looks like that. It flattens even more, and so on and so forth. This is your x squared. That would resemble x to the 4th, and x to the 6th, and x to the 8th. And then if after you say the name, say my name, say my name, and you
Mr.
go
Pileggi.
minus 2, the whole thing is going to do this. 1, 2. Just dropping 2. Got me? So let's see if we can graph that. You know, pretty quick. If it had been x to the 5th, what's 0 to the 5th? So that point would be here. But we're doing, if we use 0, 0 to the 5th minus 2 will be, so that means that the inflection drops down to negative 2. And that graph is going to do this. That's that graph. That's the graph of F. That's the graph of x to the 5th minus 2. So it has that y-intercept, and look, it's got an x-intercept, doesn't it? How do we find x-intercepts? Charles? In general, how do you find the x-intercept of a graph? Good job. Yes. You set y equal to 0, which is f of x. So to find this point right there, we're going to set x to the 5th minus 2 equal to 0 and solve for x, and that's going to give me that point. Because I need at least 2 points because I'm going to graph the inverse. I need to know what to switch. So add 2, you get x to the 5th equals 2. How would I get x if I have x to the 5th? How do I undo a 5th power? Fifth root. By 5th root x to the 5th, I get x, but then I have to 5th root the 2, and that's called 5th root of 2. So right there, I have 5th root of 2. 5th root of 2. It's an irrational number. It's 1 point something. I don't care. Exactly, it's 5th root of 2. So right here, I have points that belong to F. Belonging to F. Is that belonging? Is that belonging? Are 0, -2 and 5th root of 2, 0. So I got 2 points. Going to green.
That was about variance for f of x, right?
That's F. Belonging to F inverse are -2, 0 and 0, 5th root of 2. See, here's what I know. The fifth root of 32 is 2. Because 2 to the 5th is 32. So I'd have to go all the way up to 32 in order to get a 5th root that equaled 2. 5th root of 1 is 1. So 5th root of 2 is much closer to 1 than it is to 2. Understand what I just did? Because I got to plot that point, and like I said, that's exactly going to be called 5th root of 2, but as a decimal, I don't know what it is. So here we go. Here we go. Green, baby, green. So that is what? A little bit bigger than 1. So that would put me at about 2 right there. So if that's about a little bit bigger than 1, that'd be a little bit further out than -1, around -2, right there. So that's on the x-axis. So the point for F inverse is -2, 0. And this point is a little bit bigger than 1, 0. So the y-intercept I'm going to graph now is 0, a little bit, a smidgen bigger than 1. Not much. To help get the graph, it's going to pass through those 2 green points. To help get that graph, I'm going to graph the line y equals x. Well, here's 0, 0. If I use this as 1, which isn't a good use, I don't have this square anymore, because that's around 1, so I've got this scale off. So to do 1, 1, I'd have to go about right there. Connecting these points for this scale, for this set of x and y axes. This is the approximate location for y equals x. And so now I want to mirror the thing. So this is coming away, like so. This is going towards it and then up. See how this is going this way? This is not very well done. And then what should it do after this? See how this bows down once it passes the intercept? This should do what? Huh? Should bend away from it. It's supposed to be, that's not a pretty picture. That's my rendition. If I were sitting on sheet paper, I would try to do better than that. I'm trying to get these symmetric. I'm trying to get these symmetric. So in art, you would do better. My problem with it is I did not preset the scale well enough to make sure that the uniformity along the x-axis was the same spacing as that along the y-axis. So that kind of forced me to have a bad picture. That's not good. But what I was trying to do here, look, I was trying to get this image going. Kind of like that's not going down. It's kind of like it's going up, but it's going up gradual. My scale's not showing it. This shouldn't be going up. It should be still like so. That's bad. That's too extreme. Kind of flared out a little bit. The scale screwed it up. Any questions? All right, I'm about to take 41 down and do 43. Then I'll give you a couple more problems.